Today we will discuss about softening, spheroidization. Please subscribe my channel for more technical videos. Spheroidization is a change in the microstructure of steels after exposure in the 850 degrees Fahrenheit to 1400 degrees Fahrenheit, 440 degrees Celsius to 760 degrees Celsius, range, where the carbide phases in carbon steels are unstable and may agglomerate from their normal plate-like form to a spheroidal form carbides. Spheroidization may cause a loss in strength and/or creep resistance. Affected materials. All commonly used grades of carbon steel and low alloy steels including carbon 0.5 molybdenum, 1 chromium 0.5 molybdenum 1.25 chromium 0.5 molybdenum, 2.25 chromium 1 molybdenum, 3 chromium 1 molybdenum, 5 chromium 0.5 molybdenum, and 9 chromium 1 molybdenum steels. Critical factors. A. Metal chemistry, microstructure, exposure time, and temperature are critical factors. B. The rate of spheroidization depends on the temperature and initial microstructure. Spheroidization can occur in a few hours at 1300 degrees Fahrenheit, 552 degrees Celsius, but may take several years at 850 degrees Fahrenheit, 454 degrees Celsius. C. Annealed steels are more resistant to spheroidization than normalized steels. Coarse-grained steels are more resistant. Affected units or equipment. A. Spheroidization can occur in piping and equipment after exposure to temperatures above 850 degrees F, 454 degrees Celsius. The loss in strength may be as high as about 30%, but failure is not likely to occur except under very high applied stresses, in areas of stress concentration, or in combination with other damage mechanisms. B. The loss in strength is usually accompanied by an increase in ductility which allows for deformation at stress concentrations. C. Spheroidization affects hot wall piping and equipment in the FCC, catalytic reforming and coker units. Fired heater tubes in boilers or process units may be affected by a loss in creep strength, but equipment, in general, is seldom renewed or repaired because of spheroidization. Appearance or morphology of damage. A. Spheroidization is not visible or readily apparent and can only be observed through metallography. The pellitic phase undergoes a time-dependent transformation from partial to complete spheroidization, Figure 1 and Figure 2. B. In the case of the 5% to 9% CMO alloys, spheroidization is the process of transforming the carbides from their original finely dispersed morphology to large agglomerated carbides. Prevention mitigation. Spheroidization is difficult to prevent except by minimizing long-term exposure to elevated temperatures. Inspection and monitoring. Spheroidization can only be found through field metallography or removal of samples for metallographic observation. A reduction in tensile strength and/or hardness may indicate a spheroidized microstructure. Thank you for watching. Please subscribe my channel.